So let's go over permissions for files and directories in Linux, right? So here I have file 1 in this directory, and we can see if I do an ls-l, it's got all these funky letters here, R, W, and X, R, W, X, R, W, X. And with that, there's 3 sets of RWX, right? And each of those sets belong to a user, a group, or other. And these signify who has permissions to do what. So the first 3 are user has permissions to read, R for read, W for write, X for execute. So user has permissions to read, write, and execute. Group has permissions to read, write, and execute. And other has permissions to read, write, and execute. And we can change those permissions, and there's 2 ways to change those permissions. One way is the symbolic method, where we use letters, where we define, who do we want to change permissions? Do we want to add, remove, or set these permissions exactly, and which permissions do we want to add, remove, or set? Do we want to read? Do we want to add or remove, read or write or execute for user, group, or other? And the second way is the numeric method, which I see people use most often, and which I use most often myself. But we'll go over the symbolic method of changing file and directory permissions real quick. So the symbolic method is, first off, if you're going to change these permissions on files, whether it be symbolic or numeric, you're going to use the chmod command for change mode, because permissions on a file in Linux are a mode. And then we're going to use the who, the what, and the which syntax, right? So you're not actually going to type this in here, right? But this is how it's going to go. You're going to define who, such as user, group, or all, or other. What do you want to do? Add, remove, or set. And which do you want to add, remove, or set? Read, write, execute, right? So for who, so say I wanted to change permissions for just the user, right? And I wanted to remove minus, right? Well, if I want to change permissions for who, first I have a user, or a group, or other, or all, right? I can affect them all at once. I can, for the user group, I can add, I can remove, I can set exactly what I want. So in this case, I'm going to remove, and I can add, remove, or set read, write, or execute permissions, right? So here, I'm going to change the permissions on the file. For the user group, I'm going to minus or remove the execute permissions on file 1. And if I do an ls-l on file 1, we can see now that the X has disappeared from the user group. If I wanted to remove it from the group, do an ls-l again, the X is removed. If I wanted to add that back, right? It's as simple as changing the minus for remove to a plus sign for an add. Do an ls-l file 1, and it's back. I can do multiples at once, right? I can, let's add that back to user, right? So you can just see the difference that's going to show up here. I can change it for user, group, and other, right? And I can minus X from all of them. And now X is gone. And then the second way is the numeric method, right? So if I do a chmod, right, 777 on file 1, do an ls-l file 1, you can see it changes back from read, write for user group all to read, write, execute, read, write, execute, read, write, execute for user group all, or user group other, sorry. That's because these numbers have meaning, right? So in Linux, an R, think of it as worth 4 points, right? Think of it as a W as worth 2 points. And think of an X as 1 point, right? They each have values associated with them. So a read, write, execute would, read, write, execute would essentially be a 4, 2, 1, right? And if you added those together, if I did a 4 plus 2 plus 1, I would get 7. So when I made the chmod 777, it knew I wanted read, write, execute, because each of those 3 octets, 777, mean user, 7 for user, group for user, or group for group, 7 for group, and 7 for other. So if I wanted to, so if we know that R is equal to 4 points, right? Then if I did a chmod 4 for user, 4 for group, 4 for other on file 1, I should only have read permissions on file 1. So do an ls-l file 1, and I only have read permissions. If we know a write is worth 2, right? So if I did a chmod 222 on file 1, I should only have write commands, right? Write privileges for user, group, other. ls-l file 1, only write. If I did a chmod 666, well, what happens then? Because nothing's equal to 6, right? Well, we add them up, right? So if I have a 6, I obviously have a 4. I either have a 3 and a 3, a 5 and a 1, or a 4 and a 2. And since a 3 and a 3 and a 5 and a 1 don't exist in Linux permissions, it has to be a 4 for read and a 2 for write. So if we add those together, we get 6. Oh, I have to find my file here. ls-l file 1, and now I have read and write. And if we know execute's worth 1, right? So if I did a chmod 111 on file 1, ls-l file 1, it only has execute permissions. If I did chmod 777 for read, write, execute, read plus write plus execute, 4 plus 2 plus 1 on user, group, other, and then I get all permissions on file 1. And that's a quick overview on how you change permissions on Linux file systems and directories.